Hey, thanks for coming back to help me with this escape room at Mathlock Mansion. If you recall, we've been using our equation solving skills to unlock puzzle pieces that will hopefully lead to my escape. Can you help me tackle this next challenge? So, unlocking this safe is our next task. I see this keypad, but I'm not sure how to figure out the code. Oh, look! Here are 4 new equations. Do you think solving these equations might give us the passcode? There's only one way to find out. This first equation looks really similar to the equations we tackled last time with 2 variable terms, one on each side of the equal sign. Do you remember what to do? Oh, right. We can use inverse operations to cancel one of the variable terms.
Pause the video now and solve this equation for n. Remember, since we can do anything we want to an equation as long as we do it to both sides, there are multiple paths to the correct solution. I will show you 2 of those options here. First, you could have subtracted 1n from both sides to cancel 1n on the right. 3n minus 1n gives us 2n plus 4 on the left, equal to 8 on the right. To solve for n, subtract 4 from both sides, giving us 2n equals 4. Divide both sides by 2, and we get a solution of n equals 2. On the other hand, you may have chosen to cancel 3n on the left, which means you would subtract 3n from both sides, leaving you with 4 equals negative 2n plus 8. Then, to solve for n from here, we'll subtract 8 from both sides, leaving us with negative 4 is equal to negative 2n. Divide by negative 2 on both sides, and that gives us the same answer of 2 equals n. Pause the video here to correct any errors.
So it seems like the first digit of the passcode is 2. Let's keep going. Interesting. I don't think we've seen this before. What do you notice about the coefficients of the variable terms in equation 2? They're both negative. Well, we know how to add and subtract negative integers, so this shouldn't be any different, right?
Since we have 2 variable terms again, I'll start by canceling one of those terms using inverse operations. How can I cancel negative 2k? Well, if subtraction cancels a positive variable term, what operation will cancel a negative variable term? Yes, I can cancel negative 2k on the left by adding 2k to both sides of the equation. Negative 2k plus 2k is 0, leaving me with 3 on the left. On the right, I have negative 4k plus 2k. Since the negative value 4 is bigger than the positive value 2, the result is negative 2k plus 9 on the right. What's my next step to solving this equation? I can subtract 9 from both sides to get negative 6 equal to negative 2k. My final step is to get this k by itself. What is happening to the k? We're multiplying by a negative 2, so to undo it, we will divide by negative 2. Yes! Dividing both sides by negative 2 gives us negative 6 divided by negative 2, which results in a positive 3 equal to k. Since this was a bit new, I think it might be a good idea to check our solution. pause the video here and substitute 3 for k to check your work.
When I substitute 3 in for k, I get negative 2 times 3 plus 3 is equal to negative 4 times 3 plus 9. Simplify both sides, and I get negative 3 equals negative 3. Great! We found the correct answer and the next digit of our passcode. Only 2 more equations to go. Let's see. Oh, wow. What do you notice about this equation? These variable terms have fractional coefficients. Well, similar to the negative coefficients, if we know how to add and subtract fractions, this should work the same way, right? Let's try this together.
Because we have 2 variable terms, we will start by canceling one of them. How can we cancel 1/5 x from the left side? Since this is a positive 1/5 x, we can subtract 1/5 x from both sides. When we subtract 1/5 x from 1/5 x, the 2 terms cancel, and we're left with negative 2 on the left. On the right side, we have 4/5 x minus 1/5 x. How do you subtract fractions with a common denominator? To subtract fractions with a common denominator, we subtract the numerators and the denominator stays the same. So 4/5 x minus 1/5 x will leave us with 3/5 x. Now our equation is negative 2 equals 3/5 x minus 8. Since we have just one variable term, we can work on isolating the variable to find the solution to this equation. The fractional coefficient doesn't change how we finish solving this equation. We are still just trying to isolate the variable. So, what's happening to x? It's first being multiplied by 3/5, and then it's being subtracted by 8. What step should we do first to undo these operations? We can add 8 to both sides to make our equation 6 equals 3/5 x. Okay, now to undo this multiplication, we need to use division. But how do we divide by a fraction? Oh, that's right! To divide by a fraction, we can multiply by its reciprocal. The reciprocal of a number is just the number you get from flipping the numerator with the denominator. So, what is the reciprocal of 3/5? Exactly, 5/3. So to divide both sides by 3/5, we actually multiply both sides by its reciprocal, 5/3. 3/5 times 5/3 equals 1x. To calculate 5/3 times 6, I'll write 6 as a fraction, 6 over 1. When we multiply fractions, we multiply the numerator times the numerator and the denominator times the denominator. That gives us 30 over 3. As always, when we work with fractions, we don't want to stop until our answer is in simplest form. Can 30 over 3 be simplified? Yes. 30 and 3 have a common factor of 3, so this reduces to 10 over 1, or just 10. So, x equals 10, and those are the next 2 digits of our passcode.
Okay, just one last equation before we can try out our passcode. Based on your work so far, I think you're ready to tackle this one on your own. Pause the video now and solve this equation for n. Let's check your work.
I started by canceling 1/7 n on the right by subtracting 1/7 n from both sides. 3/7 n minus 1/7 n is equal to 2/7 n, which left me with the equation 2/7 n minus 1 equals 3. Next, I added 1 to both sides to get 2/7 n equals 4. To isolate n, I need to divide both sides by 2/7. But really that means I need to multiply by its reciprocal, 7 over 2. This left me with n equals 4 over 1 times 7 over 2, or 28 over 2, which simplifies to 14.
We did it! We found all 6 digits of this passcode. Now let me just type this in and... here are 3 more pieces of the puzzle. I hope this picture starts to come together soon. Today, we solved equations with variables on both sides of the equal sign, and they had negative and fractional coefficients. We learned that addition cancels negative coefficients, and to isolate variables from fractional coefficients, we multiply both sides by the reciprocal of the coefficient. Once you finish your guided notes, you can move on to the day 1 practice levels. And remember, math is everywhere. Keep exploring.
Hey, hey.